Well, maybe I'll just start talking a bit while those are coming up.
Please go ahead.
Thanks for the opportunity, Greg, to speak. I know that this was kind of a last-minute thing. It was an opportunity to just kind of share with the community a little bit of the latest status from headquarters, from HEO and AES on some of the commercial and international partnerships and opportunities that we're working on. I think there's a real emergence of new commercial capabilities. Jim just alluded to some of that. And in HEO, what we're really trying to do is both stimulate the capabilities for transportation to the lunar surface, and then we're very mindful not only of the technical risks and challenges, but for the commercial players out there, there are a number of market risks as well. And I think I see on my screen now, I see the slides. We can go to the second slide. So for some time, we've had this vision in HEO that we could move towards a greater role for commercial players, all in the interest of really bringing on more affordable missions. Speak to the mantra of affordable and sustainable exploration. And in AES, we're trying to bring that about through a mix of new technologies, but also through new innovative business practices. So what we've been seeing, the opportunity for some time, through Google Lunar X Prize and other initiatives, there's been increasing investment. NASA stepped in, and a number of years ago, about 3 years now, we started the first step of what we envision to be a two-step approach. First step being, well, how do we perhaps stimulate some of these capabilities for lunar landers, coupled with the emerging launch vehicles, to provide some kind of end-to-end commercial service. So we started something called Lunar Catalyst, and I'll bring a little bit of status on the Lunar Catalyst program in a moment. But basically, this is quite analogous to the way NASA stepped into the launch vehicle market with COTS, trying to help stimulate the development of launch vehicles. And ultimately, that leads to a second step, which is turning around and addressing not just the technical risk of establishing these capabilities in the first place, but then the market risk. Where is the demand going to come from? And this is an experiment that we're in. I would say this is it's going to take a number of years. It's a decade scale type of experiment of trying to create a new marketplace, essentially. So step two is NASA being one, hopefully, of multiple customers, government and private sector combined, that can collectively bring about a new market, like I say, both the supply of capabilities and then the demand to sustain that. So next chart, please, and I'll just kind of run through where we're at with Lunar Catalyst. I think everybody, or many folks in the lunar community, have heard this before at league meetings and whatnot, but Lunar Catalyst is an initiative that we've invested about $10 million a year, going on a third year of partnerships with 3 companies, Astrobotic, Mastan, and Moon Express. These were competitively selected and the criteria for selection included both technical and business related criteria. So did these guys have a business plan and a market strategy and investors and customers, in addition to having some technical credibility? So that's how we ended up with these 3 partners initially. We've been flying under the radar. Not this is I likened this to COTS for launch vehicles, but it's a very small version of it. We're not throwing lots of tens or hundreds of millions of dollars at this by any means, and we're not paying these partners at all. It's all in-kind contributions, but it's been very substantial. I think if you have talked to any of the Lunar Catalyst partners, I think you'll hear consistently how much they've relied on NASA to help them focus their efforts, avoid a lot of missteps in their design and development process. And we're leveraging Probably upwards of 3, 4, 5 dozen NASA engineers who have been working on lander technologies at almost all the centers, heritage from most recently of our Morpheus and Mighty Eagle project. So it's been a very rich and tight collaboration, providing design, development work hand in hand. And as we get closer to launch with some of these, some of our partners, we're moving more into large-scale testing activities, and we'll talk about that. So let me go to the next chart with a little more detail on each of the 3 partners. So here's just a snapshot on Astrobotic. They're based out of Pittsburgh. All these companies are 20-ish or so people, very simple and small, nimble companies. We've got technical and financial milestones established in the Space Act agreements with each of these, and so they've been marching through and checking off technical and financial milestones. So in Astrobotic's case, they've completed about 7 out of the 20. So they're making progress. They're not making progress as quickly as envisioned when we started the Space Act agreement partnerships, but really, I think what we're seeing, what I've learned certainly personally, is how dynamic, in fact, the sort of the entrepreneurial community is and needs to be. Each of the partners has undergone some twists and turns. They have started in some cases with large ambitions for larger landers, and then reality has set in and they've re-vectored a bit. So there's no doubt that the technical challenges are real for these guys. They're coming up to speed, but they have been making substantial progress, and that has been quite encouraging. From a NASA perspective, some of the NASA investments, things like core flight software, that has been an initiative out of Goddard a number of years ago. It's been promulgated across a number of NASA programs, trying to invoke it as a standard. Well, through efforts like Lunar Catalyst, we're now reaching out beyond just the agency and indeed to the broader commercial sector to infuse that. So in fact, all 3 Lunar Catalyst companies have incorporated core flight software, which, if you don't know, it's this architecture that includes a number of sort of a basic executive software suite and a software structure with NASA-developed apps that hang off of it, and the ability to accommodate user-provided apps. So that's what's going on, is they're incorporating this particular NASA software into their flight systems, and then developing more apps that are specific to their own companies. And that's just one of many examples of the kinds of interactions going on. There's all kinds of design analyses, mission design and trajectory analysis onto every subsystem discipline for the spacecraft. In the Astrobotic's case, their lander is called Peregrine. You see a snapshot there. They completed a PDR, and they're still working on their propulsion system is undergoing a number of design adjustments at the moment, but they have some heavy hitter partners as well. Airbus, for example, which is building the landing legs. And in addition to what their partnership with NASA, again, we're continually monitoring their ability to raise capital and partnerships. They've got sponsorships, and they've got customer agreements that they've been collecting over time. One of the interesting things we're seeing about the marketplace is that in addition to private customer demand, which might be things like so cremains, sending cremated remains to the moon, or a variety of media related, high definition TV, those kinds of things. Astrobotic is finding a lot of other space agencies wanting to sort of buy exploration by the yard, avoiding large, $500 million, $1 billion initial capital investments which is a huge entrance barrier, of course, and being able to scale that down substantially and open possibilities up for organizations such as, say, the Mexican Space Agency, or even our traditional partners. They have an MOU with DLR. So I think space agencies are finding the commercial model allows them to maybe make more modest investments over to maybe a larger number of smaller, more modest investments rather than having to invest in one large mission. So it's an interesting development in the marketplace we're seeing from Astrobotic. Let me go to the next chart. I'll say a few words about Mastan is the next one. So Mastan, they're out in the Mojave Desert, and these guys have a lot of propulsion and GNC experience. NASA has a relationship with them in a variety of ways. The Flight Opportunities Program and STMD has used their DTVL lander test beds for a number of years to fly payloads. And so they're building on that expertise and have designed a lander called XL1. I didn't mention that with Astrobotic, but these initial landers, we're talking about, maybe tens of kilograms, or XL1 actually, I think they're aiming for over 100 kilograms of payload to the surface initially. And Mastan's approach is to develop a terrestrial version of that XL1T, which is what their main focus is right now, so that they can test that out in the desert. It's highly analogous to their lunar design variant, but focused on exhibiting terrestrial test capability. So they're both Astrobotic and Mastan are probably a few years out still. 2019. I think Astrobotic's saying 2020 timeframe for their first missions. Mastan has actually all these catalyst companies have ambitions to scale up over time to hundreds of kilograms or even tons. You see the Zeus lander. Some of you are familiar with that. This is a partnership between Mastan and ULA to use an upper stage. Centaur originally, and now the ACES stage for ULA. So this
Nantel,
could put
two minutes,
potentially multiple tons of payload on the surface. So again, NASA's working closely with these companies. A lot of propulsion activity. We're working with them on a number of propellant combinations. Some are sort of green hypergol type propellants. Others are looking at lots of methane as well. Mastan.
Nantel.
Next chart.
2 minutes, Nantel.
Okay, thanks. Finally, Moon Express. There you see a picture of a tethered flight, and I think the thing with Moon Express is they have a mission that they've been aiming for the end of this calendar year. I think that will be highly ambitious to achieve, but they are advertising that they have an MX-1 lander. They about 30 kilograms of capability of payload to the surface. Next chart. So I do want to mention some RFIs that we have gone out with. Many in the community are very well aware of these, but this is an attempt to do some market research and put us in position to go out with some solicitations. There was one in the fall on small payloads. We got 40 responses. Again, NASA's interest here is to maybe start small and scale up over time. We went out collectively with the science director, mission director, and the STMD on a transportation services RFI in May, and have been analyzing the results. We got about 14 responses. A variety of credible transportation providers are emerging, not only the catalyst companies, but others. And so the intent is to go out with some solicitations. We're planning those now, and there's some policy discussions with the ninth floor, very active discussions now. But we anticipate new solicitations for both of these areas, acquiring payloads and then looking for ways to transport them. The catalyst companies are definitely focusing on smaller payloads initially, and there may be larger payload classes as well. So we're trying to determine how to structure those solicitations, or the transportation solicitation. So stay tuned for that. Next chart. I just there's just a couple charts to quickly mention some of the international activities going on. The ISEG, International Space Exploration Coordination Group, very much looking for ways to optimize the collective output of the various missions being planned for the moon. It's an opportunity for us to gather collectively. And right now we actually have an effort. It's a multi-mission coordination dialogue for the lunar polar missions in particular, and everyone's involved: the Chinese, the Russians, the Europeans, Japanese, etc. We've enlisted the league to support this effort, so they're helping us with some analysis on, again, how we might devise some strategies to attack the strategic knowledge gaps collectively, again, in the most efficient manner. So we're working on that actively here this summer and fall. And then one final chart just quickly to show, we've also had a number of virtual workshops through ISEG focused on the Lunar Polar Volatiles Challenge, and so there's a lot of material online at lunarvolatiles.nasa.gov that captures some of those workshops. Again, trying to bring in perspectives from the broad community and bring those to the attention of the ISEG space agencies. So there's a lot of activity going on. Just last couple of weeks, ESA, for example, has announced that they're going to have a solicitation for an ISRU mission definition activity, a 2025 mission they're looking at. So a number of agencies around the world are ramping up their activities with regard to lunar payloads and innovative ways, including commercial approaches to deliver these payloads to the lunar surface. So that's it. I'm happy to take any questions if there are.
Thanks very much, Nantel, and thank you so much for agreeing to do this at relatively short notice. We were running a little on the late side, so let's just take one or perhaps two questions. Are there any questions for Nantel? It doesn't look like it. Okay, all right. Well, Nantel, thanks again. We really appreciate it, and I know it's a late hour there on the East Coast, so thanks again for jumping in at the last minute and doing this. It was a great talk. Thank you.
My pleasure.